All right. Good morning, everybody. This is lesson 2 of Unit 7, CP2. Today we're going to talk more about angles inside circle. We talked about central angles yesterday. We're going to talk more about inscribed angles and do some stuff with chords and all that stuff. Yeah, should be good. Let's roll. Oh, should I do some kind of cool intro? Dang it. This is going to be the best lesson ever. Yeah. Okay, central angle has its vertex at the center. Oh, go figure. That's why it's called the central angle. All right, so AOB, AOD, COB, and COD are all central angles. What would the measure of those four angles have to add up to? 360, yeah, because those four angles form a circle. They must be 360. So let's talk about AOB for just a second here. That angle, let's say that angle is 62 degrees. We can then say that the measure of arc AB would also be 60 degrees. Okay. Arcs have measures, and so do angles. And they are always, if you have a central angle, it's equal to its intercepted arc. So angle AOB equates to the intercepted arc, which we call AB. Okay. AOD would correspond to the intercepted arc AD, etc. So that's just a little bit on central angles. A central angle's measure is equal to the arc measure that it intercepts. Waiting. Let's pause this bad boy. Actually, I want to do a quick example here. Let's say I have A, I have B, I have C, right? And let's say that AOB is a central angle with a measure of 88 degrees. Okay, I want to know two things. What would the measure of arc AB equal? And then I want to know what the measure of arc ACB equal. I want you to take just 30 seconds, talk to a neighbor, see if you can figure out those two arc measures. Okay, I need to correct myself on this previous example I did. This should be a 62. I don't know why I put a 60 there after putting 62. These two angles should be the same. If that's true, what should the measure of this arc be right here? 88. If that's a central angle, that should be 88. What would the major arc be that complements that? What would this arc's measure be? Well, I know there's a relationship. What do the red and the green arcs have to add up to? 360. So that'd be 272. Sounds good to me. Okay. All right, let's keep moving. Let's talk about inscribed angles. Okay, now I want to draw an example of just one inscribed angle instead of a central angle. So here's a circle. Let's say I have A, I have B, and I have C. An inscribed angle is an angle whose vertex is on the edge of the circle instead of in the center. Okay, now the relationship in this case is a little bit different. If this was, let's say, 32 degrees, what would its intercepted arcs measure be? It's not 32. It's not a central angle. What do you think the relationship would be? Do you think the 32 would be smaller or bigger than the arc measure? Smaller is a good choice, right? How much further is this point from the opposite side, this arc? It used to be here. How much further has it been moved? It's been doubled, right? So the angle has then been halved. So the measure of arc AB would be double whatever the inscribed angle's measure is. Okay, so the inscribed angle's measure is 32, therefore its intercepted arc would be double that. Would be double that. Okay, so if I look at this arc right here, or this angle, is this an inscribed angle? Right here, ABC. Yes, it is, because its vertex is on the edge of the circle. If this was 10 degrees, what would this arc's measure be? 20. Good. Okay, let's look at another one. How about BCD? Is that an inscribed angle? Yes, it is. If I told you that the measure of this arc right here was 140 degrees, what would you say that this angle measure is? Say again. 52? Is that what you said? Somebody said 52? Okay. What's the relationship? We said this gets multiplied by 2 to get that. So this gets multiplied by 2 to get that arc measure. So this should be 70. With me? Okay, it's just a relationship of 2 to 1. Okay. I'm not going to draw another one up there because I think we'll just have too much going on. Okay. All right, inscribed angles. That's the basics. Let's keep going. So I want you to at least see a visual of this, right? Oh, I can't drag it because it's a PDF. Dang it. Okay, I'm going to skip that slide. All right, if the measure of, golly, this is really fun to work with. If the measure of angle ABC here is 17, is that a central angle or inscribed angle? Inscribed. So what would the measure of arc AC be? Yeah, double that, 34. Okay, can you multiply by 2 or divide by 2? I think you can. That's all we're doing in this portion of the lesson. Okay, now we get to the chords of central angles. If two chords, what's a chord? Oh my gosh, what's a chord? This is a chord. A chord is a line segment inside a circle whose endpoints are on the circle. Right, that's a chord. And we're saying these two chords have the same length. What does that tell us about the blue angle and the red angle? What do you think? If their chords are the same length. What would these two chords tell us about these two arcs? That'd be the same, right? And if both of those arcs are the same, then both of their central angles are the same. So if I called this angle number 1 and I called this angle number 2, if their chords, okay, if their chords are congruent, then the measure of angle 1 should be equal to the measure of angle 2. That doesn't look accurate to me. I think, you know, you got to go by markings, but this is, I don't necessarily look at that and say that that arc would be the same as that arc, but go with it for now because when I created the slide, I was, you know, probably had a 3-year-old and a 1-year-old, and it was tough times. Right? It was tough times in the hood. Oh, Laconia. Okay. All right. So we know then that those two arcs, right, would be the same. We know those central angles would also be the same. Okay, now let's highlight the radius here. Is this a radius or a diameter? That's a radius, and that's a radius. What do I know about the radius in a circle? Would those two be the same length or different lengths? They should be the same, right? Now, if that radius is perpendicular to a chord, then it bisects that chord. Does that make sense? If it's perpendicular to the chord, then it also bisects that chord. Now, it doesn't guarantee that those two chords are the same length, because what I could do is I could draw another chord like this, I could draw another chord like this, and like this, and like this, and it might be perpendicular to all those and bisect all of those, But all those chords aren't the same length. As you get closer to the center, it's going to become a longer chord until we get to the longest chord, which is the diameter. So if a radius is perpendicular chord, then it also bisects that chord. All right, let's continue. So taking that a little bit further, if the two chords are the same length, then that means that they are the same distance from the center, which makes total sense, right? If you draw a circle and you draw two chords that are the same length, then they have to be equidistant from the center, right? If I were to draw a second example, I can make it more clear that the alternative is true. Let me draw a really short chord, and let me draw a really long chord. Well, which one is the center closer to? The really long chord, right? So the longer the chord, the closer to the center it becomes. If two chords are the same length, then of course they'd be equidistant from the center. All right, let's see what else we got here. And that's it. Should we do a couple of these problems together? Yeah, sound good? What would be the measure of AB? 165, right? That's a central angle, so AB would be 165. Let's note where AB is. Would AB be the long way or the short way? Yeah, it has to be the short way, right? We always use two letters for the minor arc. Okay, so that'd be 165. What would the measure of, ooh, this is a funky one. CD. Ooh, this is a good one. I want to know the measure of this arc. Well, I know the measure of this arc. That's 20. I know the measure of this arc. That's 128. What would be the measure of this arc over here? 128 as well. If these two chords are the same, their intercepted arcs are the same. And now I can do a little bit of math because that's what I get paid for. What do those four have to add to? Yeah, 360. Okay, I add them up, subtract a little bit, and I got my question mark at that arc. Cool. Now let's see here. Let's pause the video for a second. Here we go. Okay, so what do I know? I know AB and CD are the same length. Okay, so let's label that. That tells me that AB and CD are the same length. If two chords are the same length, what relationship do they have to the center of the circle? Same distance. So that means PO and OQ are the same length. So PO is 8. Oh, so that means OQ is 8. And that means we're done. Ciao. Depends on the day. Yeah. But I got a piao on my YouTube comments the other day. Yep. I'm not going to say who because whatever. You can look it up. Clickbait. Oh, this is a good one too. Should we do this one? Ew. Oh, should we do all of them? I'm feeling it. I'm feeling it. This is not working well for me right now, though. There we go. Okay. AB is 6. Okay, so I'm going to label AB. I'm going to put this in red so I remember it's red. That's 6. CD is 8. CD is 8. 8. So is AB or CD closer to the center? CD, right? The longer chord will be closer to the center. Okay. So BD is 6 as well. OP is 4. I'm running out of colors. OP is 4. I'm going to label that 4. And OQ is 3. Might as well put numbers on them. BD 6. AB 6. Okay. What is the perimeter of OPBDQ? Oh gosh. OPBDQ. Ah, this is a really good question. I'm going to shade in OPBDQ so I know what I'm talking about, this pentagon here. So the only thing in question is, what is this side's length right here? How do you know it's 3? Because the radius does what to the chord? It bisects it because it's perpendicular, right? So that means this will be 3. So OPBDQ will be 3 plus 4 plus 3 plus 8 plus 6, which is whatever that is, 24 maybe, I think. Don't forget Charlie Mike on the end. Thank you. Yeah. Wouldn't that be, we got to do the midpoint thing twice, right? Ooh, that'd be 4. Thank you. So that changes that to a 4. That changes that to a 20. Way to go. Like, subscribe, comment for Bryn below. Yeah. We good? Thanks, Bryn. You guys got to step up and tell me when I'm wrong, because it happens often. My children and my wife don't hesitate, so might as well just keep it true all day long.